So this was my very first tube amp. I got this tube amp when I was about maybe 7 or 8 years old. This amp came out of an old organ, Thomas Talking Organ it was called. It was an electronic organ that had a built-in ceramic turntable, and this was the amp that powered it. It was stereo. This is a very straightforward amp. It's a what's called a Williamson design. It has a 12AX7 input stage, which is very, very common in this era. This was designed probably in the 60s. And a 12AU7 for the phase splitter, and a concertina setup, and then two 6v6 GTs pairs in a push-pull arrangement. This is the rectifier diode here, 5U4GB, and this is a little voltage reference tube that was used as part of another circuit. So there were two other tubes here originally, and this was not, this chassis was all just, you know, raw metal. The other tubes were for a vibrato circuit and also another part of the organ circuit, and this tube was the reference for that. And on the back there what used to be a large connector that had a power harness that came out, and it went to another chassis that had a preamp on it. It had the phono preamp, it had all the volume and treble and bass controls, and also it had the inputs from the organ part of the circuit. And then there was another chassis elsewhere in the organ that had all the oscillators. So all that is long gone, but for some reason I kept this amp even though I didn't use it. But you know, I grew up listening to all of my music probably until I was an early teenager through that thing. It had an auxiliary input in the back of it, and I hooked up my tape deck and my stereo through it. It had huge speakers, and it sounded pretty good. You know, it wasn't super hi-fi or anything, but for a kid it sounded nice and loud. So anyway, yeah, we trashed the organ eventually, but before we did, for some reason I pulled this thing out and stuffed it in a closet. And then some years later I pulled it out and started messing around with it. And you know, it was funny, after I fixed it up and kind of hooked it up, jerry-rigged it a little bit, and I thought it sounded great, and it still had its original tubes. You know, they're decades old at this point, and they were pretty tired, especially the output tubes. But I really liked how it sounded. I guess just having grown up listening to all my music through this thing, it really sort of influenced me, and I really liked how it sounded compared to the solid state amp that I was using before that. So, but it kind of went back into the closet because it was very exposed. There were all kinds of wires hanging out of it, and a bunch of tubes that one of them was fried, and I just didn't feel safe using it, so I set it aside for a while. And then some years later, after I came back from college, got a job, I went digging and found this thing again in my parents' house, and I decided to fix it up. So I stripped it down, painted the chassis as you see here. I didn't paint the power transformer. I never did get all the rust off of it. But most of the work is on the underside. So here's the underside of the chassis as it exists today. I'll throw up a picture of what it looked like before I rebuilt it. Most of the components have been replaced. Some are original. Obviously the power transformer is original. These power resistors are from the original circuit. Or these two are, at least. The multi-section capacitors, this one and the one you saw on the top, are new. Well, they were new 15 years ago. This power socket's new. It just had a 2-prong cord originally. And then, yeah, so here's a power switch that I added to the front. And this connector is not used for anything. It was originally like a Leslie connector for the organ. So these little pots here are the bias. So this is a fixed bias amplifier, which is kind of surprising, but it had no bias adjustment. So I added these, and I actually tried to bring the bias, get a little bit more out of the bias supply, because it wasn't enough to actually bring the replacement tubes under control. So all the tubes that were in here were branded Thomas, but Thomas didn't make tubes. They were, I believe the 6v6 GT tubes were Philips. And so I went out and found these Jan tubes, 6v6 GTs. You know, these are a little more modern, but Jan is a joint Army-Navy. They would stockpile these for their equipment, and as they sort of obsoleted the equipment that depended on these, over the years, these would kind of come out on the market. They would kind of flood the market with them. And I got lucky. I bought these probably almost 20 years ago now. But these ran really hot because the bias supply on this, it's a fixed bias amp with non-adjustable bias points. I guess they tried to make it cold, but it was way too hot for these tubes, and so I had to get a little bit more out of the power supply. These would actually glow red lines on the plates because it's a beam tetrode, so the electron beam was hitting the plate so hard it would glow red. It sounded fantastic when it was running like that, but not good for the tubes. So these are the 4 adjustments for the bias points. Like I said, originally it was a fixed bias amp, but with non-adjustable bias points. And I needed to get a little bit more out of the power supply. It had one of those really early sort of plate diodes, selenium diodes. And so I put in a Schottky diode and a nice big capacitor, which gave me a few more volts out of the bias power supply. And that was enough to get those tubes reasonably down, but they still ran kind of hot. The old wax coupling caps I replaced with these Aura caps, which are great film, metallized film caps, very transparent sounding caps. Just about all the old carbon composite resistors I replaced with these Vichy Dale film resistors, which are non-magnetic and sound great. The only 2 original parts that are left are in the feedback circuit over here, the cap and the resistor I left in place. For the feedback, these fuses here, this was my way of measuring the bias. So what you do is these fuses are not there to protect the tubes. That's not really feasible to do with a fuse. They're just way oversized, and what I do is I pop them out, I put meters across each one all at the same time, and that's how I set the bias on the amp. And that's what I'm going to do. That's why I have it on my bench. I haven't checked it in many years, so I'm going to tune it up and make sure the bias is all set evenly. The tubes I'm running now are these tongue sole reissues. These are not really tongue sole. So there's a company called New Sensor that has been buying up all the old tube names from the days of yore. So they've bought tongue sole, they've bought Millard, they've bought all the ones that you'd recognize, and they license the names in the US and other countries and sell under those brands. So, but inside is just a 6v6 made by a company called Reflector in Russia. So here is a Electro-Harmonix Tube, also made at Reflector. So you can see that the inside arrangement is a little bit different. The Electro-Harmonix has the getter at the bottom. You can see the little pan there, whereas this one has the getter at the top, just like a real tongue sole. But the inner structure is different. So the plates sit way lower to make room for the getter in the tongue sole. But the actual structure of the anodes is pretty much identical. The top wafer is identical. The bottom wafer is different, as you can see. But actually, this is a good 6v6 tube. So most of the, back in the old days, there was an equivalent Russian tube, and I can't remember the number off the top of my head, that was close to 6v6, but wasn't quite there, so it's kind of a long story, but the 6v6 tube, amp designers tended to push these tubes really hard because RCA and GE sort of over-designed them, and if you looked at what the amp designers were doing in terms of the circuit design, they were overloading these tubes by quite a bit. But the tubes of the time could take it. But the problem was when those factories shut down and all that was left were these Russian factories and the Chinese ones, they were building their tubes to the original specs, and they couldn't make it in a lot of guitar amps, and this is technically an instrument amplifier, so it was similar. So one new sensor worked with Reflector to modify their 6v6 design on this Electro-Harmonix and released it as Electro-Harmonix, and yeah, this tube got a really great reputation for being able to handle the higher plate voltages in a lot of guitar amps that the previous Russian tubes couldn't handle. So this tungstol is a good tube, a solid tube. It can handle the really high voltages in those guitar amps that are bending the specs a bit, including this amp here. So it's a decent sounding tube, but it's not really a tungstol, so keep that in mind. This little circuit board here is a DC power supply for the heaters. So the 12AX7 tube, that's the input tube, those are very high gain, and they have a reputation for being a little noisy. It's not always the tube though. Sometimes it's the plate resistors on the anode, and also there can be sometimes, depending on the tube design, some coupling between the AC heaters and the cathode, and you'll get a little bit of hum. And I was picking up a bit of hum on this one, so I built this power supply. It's off the 6.3 volts of the main transformer, and it just uses some Schottky diodes to get as much headroom as possible to bring the voltage up to high enough that I can regulate it back down to 6.3 volts DC. So the input tube and the phase splitter are on DC supplies. The power tubes are still on the AC. And I added these jacks to for the inputs, and then these speaker connectors for the output. Originally it had like a funky Molex connector on the side here for the speakers. So the input tube here, it's a RCA black plate 12AX7. I put a black plate here because, again, I wanted a quiet tube, and this was a very quiet tube with a long plate RCA. And then the phase splitter is also an RCA black plate, but at the time that I bought these about 20 years ago, they were pretty cheap. Nowadays, you can't hardly find them. So you'll see how small these output transformers are. The power output to this amp is somewhere around 12 to 14 watts. But even for that, these are kind of small, I would say. I mean, you can judge an output transformer by its weight, and these are not very heavy transformers. But with the amount of feedback that the circuit has, this amp performs pretty well. It's got a pretty flat response, up to about 10-12 watts, all the way to 20K, down to 20 hertz. So it's not bad. Alright, so I'm going to bias up this amp now. I've removed those fuses that I mentioned before and put a meter across each fuse. So each of these meters are in current measuring mode, and they're taking place of the fuse. That's how they're going to measure the current through the cathode of the tube. And then this yellow meter here is connected to the plate supply, so we can measure that. So I don't like to poke around in tube amps with a meter, so I bought these meters from Harbor Freight. They're like $1 each when they're on sale, and you just can't have too many meters, so I just hook everything up and then I turn it on, so I'm not poking with my finger around hundreds of volts. So anyway, let's fire it up here. It's a directly heated diode, so it comes up really fast. We're already up to 380 volts. And we're dropping down to, it's like around 330. So the next question is, how do you choose your bias current, right? So it's a common question. You can look in your amp manual, and they may give you a recommendation. Obviously this amp has no manual. So the way you figure it out is you have to decide how much you want to trade off tube life for sound. So these types of power tubes, they are more linear when they're driven harder. It moves them up to an operating point where they're more linear. But the harder you push them, that you shorten their life, because the cathode emission, the coatings on there will start to wear and they won't emit as many electrons, and also the plates get hot and will outgas, which wears the getter. That silver coating on the inside of the tube is there to absorb any air that's floating around in there, and heating up the metal that hot will cause gas to come out of the metal and will wear the getter, and eventually the tube will become gassy and leaky and will fail. So anyway, the way you can calculate how you want to do this trade-off is by looking at total dissipation of the plate, and that's what I'm going to do. So these 6v6 GTs, these higher power ones, are good for about 14 watts on the plate. So I'm going to bias them for around 12 watts. So we've got about 330 volts on the plate right now. So you take 12 watts divided by 330. And that gives me about 36 milliamps if I want to drive them that hard. But I want to take them like 80% of that. So take 80% of that, that gives me 29 milliamps. So I can see I'm kind of all over the map here. I've got 30.6, 33, 27, 29. So things have changed a little bit. As the tubes age, they sort of shift. So now I'm going to adjust them to get them kind of in the ballpark and make them equal. Now, I may not be able to get them all the way down to 29. I'll get them down as low as I can, because again, I'm kind of limited by this bias supply, how much I can really bring them down. Now I just have to remember which knob does what. Okay, this second one was that guy. I remember I mixed these up when I built it, and I just left it. 29.5. There we go. Got 29.34 on all of them. So yeah, all biased up. It's always nice to have a meter on the B+, so you know when it's totally discharged. So there's no voltage on this anymore. So yeah, this is my first tube amp. I call it the Thomas power amplifier because it's the power amplifier that came out of that Thomas organ. So despite the little transformers and the only 10 or 12 watts I can get out of it, it can rock. It also has that cool tube glow, the blue glow on the glass of the power tubes, and that purple glow from the voltage reference. So anyway, thanks for watching.